Hi, I'm Andrew Dubber, I'm Director of MTF Labs, and welcome to a new year and an all-new collection of conversations with brilliant minds from the global MTF community. This is the MTF Labs Podcast. Now, if there was one thing I didn't expect to be discussing right off the bat in 2021, what with everything that's going on in the world right now, it was blockchain. So the 5-day MTF Blockchain Labs in Berlin back in 2016 resulted in a white paper that laid out not only the potential for the technology, but also its shortcomings, which were, spoiler alert, substantial, especially when it comes to the concept of making the music industries more fair, in inverted commas. Not only was it difficult to encode that within the technology, one of our key findings was that despite, or maybe because of, getting all the stakeholders in the same room for a week, the problem of what fair actually means was not something we were able to definitively solve. So while the technology may have been, at least in part, up to the task, the concept of what music making means and what might be considered appropriate attribution and remuneration was not. Just over a year later, we ran MTF Labs in Helsinki, which not only revealed new capabilities and new categories of virtuosity for human beings through brain-computer interfaces and explored accessible music technologies and biofeedback, it also established new ways of recording, tracking, and tracing intellectual property live in real time at the point of creation using distributed ledger technology, which is what blockchain essentially is. But over the past few years, while we've been continuing to refine and develop this IP management concept further through the Industry Commons Foundation, the word blockchain has kind of left the limelight. It's no longer the sort of buzzword and catchphrase it used to be. It's thankfully no longer wrapped up in the cryptocurrency gold rush in quite the same way it used to be. And some of the more sensible and practical projects that have built applications on top of that technology are kind of reaching maturity now without relying quite so much on the hype. A really good example of this is Imogen Heap's Creative Passport, which A, is definitely worth checking out, especially if you're a music maker yourself, and B, doesn't even mention the word blockchain on its website. So at the risk of being, I guess, intellectually unfashionable, I wanted to start this year with a conversation with two brilliant women who have no problem putting blockchain front and center. From Germany, in the heart of the Max Planck Digital Library, the founders and builders of bloXberg have created a blockchain infrastructure that enables collaboration and establishes provenance among the global scientific research community. And they are, as you'll hear, two women who like to think several years ahead of where we are right now with the technology. I'm delighted to be joined by Sandra Vengadasalam and Friederike Kleinfercher. Hello to you both. Welcome to MTF Labs, and I guess Happy New Year.
Thank you so much. Happy New Year.
Happy New Year, Andrew. Thank you.
So obviously we're back in lockdown and you're not in the same room together. Where do we find you today?
We are both located in Munich.
Well, Sandra, you're the head of digital labs of the Max Planck Digital Library, which is part of Max Planck Society. And Friederike, you're deputy head. So let's start with, what is the Max Planck Society?
So the Max Planck Society is one of the biggest research organizations in Germany. And the strength of the Max Planck Society is basic research. And Digital Labs is part of the Max Planck Digital Library, and it's a central service unit for the whole Max Planck Society, and by the way, the biggest digital library in Europe.
And so that means, no, you better tell me, what does it do?
So our normal business, I would say, is license management of publications, ebooks, journals, articles for scientists, and software also. And especially in digital labs, what we are doing is looking and searching for tools for researchers and scientists, especially at the Max Planck Society, and providing tools which researchers could need in their labs, for example, or daily work.
So I guess strictly speaking, more technologists, not specifically librarians.
No, we are no librarians. So the nice thing in Digital Labs is that we can look at the new technologies. So we do the cool stuff. And so in the past few years, we looked for blockchain technologies, AI technologies, and and we try to find out, is this just a hype, or is this something we can provide a sustainable service for our researchers? So we are playing around with technology, and at the end, hopefully a useful service comes out.
Now, I've spoken to a lot of people over the past couple of years who now completely dismiss blockchain and think it was all hype. That wasn't your conclusion. You don't think that blockchain's just a fad?
No, we don't, actually. So we just built up a blockchain for science beginning of last year. And we think that blockchain technology is the next email, internet thing which everybody will use. And this is because of we really need decentralized infrastructure also in the scientific world, and blockchain can perfectly provide this.
So what's the issue here that you're using blockchain to address? Is it the IP thing? Is it all about attribution, verification, redefining how research works?
Yeah, so it's all of it. So science is very much with the... Yeah, we have a lot of man in the middle in science. So we have publishers, so we have funding organizations. So it's very centralized. And we would like to give science back to the scientists so that they can publish their publications directly without publishers. So they can search for grants and give out money to other researchers directly. So without central institutions. And this can be done over the blockchain via smart contracts.
Now, one of the problems that we ran up against when we were investigating blockchain technologies in the context of the music industries was that it's, how do I put this, environmentally catastrophic, specifically in how much energy it uses through the whole proof of work thing you need to do to keep it honest. Is that something you've managed to solve? Is there a workaround?
Yeah, there's a workaround. So mainly the criticism about pollution and energy consumption, this is based on the consensus algorithm, which is used in a lot of blockchains. So especially in the Bitcoin blockchain, there's proof of work, which is very computing intensive. And we changed this consensus algorithm to proof of authority. This means we do not have to compute an arbitrary problem. So our blockchain is based on reputation of the organizations which are in the blockchain. And this means that we are consuming, I could run a blockchain node on my laptop here easily. So it's not very computing intensive.
So I guess not your grandmother's blockchain. This is something that's not built on the same principles as the ones that we might have heard of, like, I don't know, Ethereum and so on, right? Is that because it would be unsustainable?
This was one reason why we decided not to go for a commercial or a common blockchain like Bitcoin or Ethereum. This is the reason why we thought we need an own blockchain, especially for science. And it is consortium driven, so to say. So behind this blockchain are universities and research organizations from all over the world.
Such as, for example?
Max Planck Society, ETH Zurich, University College London, Georgia Tech, and University of South Africa. So at the moment we have more than 45 institutions and universities from all over the world, as I said.
Okay, so you've got some big names from the world of academic research on board, which is fantastic. But let's work on the idea that I don't know anything about blockchain technology, but I have a reasonable idea about what researchers do, and that they're all gathering lots of data about the world to come to some important conclusions. And at some point along the line, bloXberg comes in to help as a technology. How does it actually all work? Are people putting all their data in there?
First of all, bloXberg is an infrastructure, and it does not serve any kind of research data. It is really an infrastructure, and we do not save any research data there, but we save hashes there. Because in science, almost safe data is done by the institutes, by the universities already, and often they have their own rules how to properly save research data and publications, whatever. And so this is an infrastructure, a backbone, and we do not save any kind of data, but the hashes. And now it's getting a bit complicated, and no for the blockchain lingo. But this is quite important for research organizations to know that their research data is still saved within their infrastructure. And they can use bloXberg and this technology for certifying or for blockchainifying data.
Basically, what you're saying is it's not about storing the data, but about logging who has created the data, who's done the research, where and when a particular important discovery was made, and so on?
Yes, it is. So this was the first very basic use case we introduced on the bloXberg blockchain. It's certifying of research data, and all universities have problems or legal cases. So who was there first? Who was in the possession of the research data when this was published? And this goes up at Max Planck Society, even at the Nobel Prize level. So it's really important to certify your data and that you can claim you had this data at that time. And this was the very first use case. So we started providing a service for our researchers where we certified Max Planck research, but we did that as a Max Planck service unit. So this is not very valuable. And this is where we thought, okay, so what can we do to make this more legal or when it comes to court? And then we said, okay, probably we should have a decentralized infrastructure where research organizations against themselves certify that this data was created at that time. And then we came up with the blockchain technology. So there are now 45 research institutions from 23 nations, and they all certify against each other that a certain research data was created at that time. So this is the very basic use case we implemented.
How do you deal with the fact that the rights accorded to researchers is going to be different in different places at different times in different contexts? Like, for instance, I know here in Sweden, even if you're full-time employed by a university, if you make a discovery or come up with some new idea, that's 100% yours. You own it. They take no ownership or claim over it, and that's different pretty much everywhere else. So I guess there's a fair degree of complexity at play here.
And this is one of the interesting points in research. If you ask researchers for what are you afraid of or what is your fear, and then you always, and this is, it doesn't matter which discipline you're doing, your PhD, your master thesis, whatever, is, oh, I'm super afraid to get scooped, which means that my colleagues or my competitors publish something earlier than me, and then maybe my research for the last 3 years, I can't publish it anymore. And this is something, and it starts even before you think about the publication. It starts already when you want to share your PowerPoint presentation, some pictures of your last microscopic data, whatever. There's always the fear, okay, what can I give out? And do I have, what about my intellectual property? Can even be a hypothesis, an idea, written something on a piece of paper, whatever.
So what we do with the bloXberg blockchain is that we cannot change like the legal system. So because it's really different in different countries, as you say. So, but what we can do is that we give the legal system where the researcher worked to certify their data like an additional hint. You know, when they go to court and they show their bloXberg certificate claiming that he uploaded his data at that time with the certificate, it's a hint which the court can claim or not. So I know that in US it's already valid. So if you go to court with a Bitcoin transaction, for example, then it matters in legal cases. So in Germany, it's a little bit difficult, but we think that in future it will become more and more, and then you really have an advantage if you do it via the blockchain.
All right, so I guess my question is, why is it you personally who's behind this? I mean, what was the journey that brought you to the place where you're coming up with blockchain infrastructures for scientific research?
So from my background, I was a scientist in my former life. I did my PhD in epigenetics and chromatin remodeling. So I know a bit at least the world and science and the fear of getting scooped and so on. And I would say in the Max Planck Digital Library, we talk a lot to our scientists at the Max Planck Society. And we visited them at the institute, stand in front of their research in their lab and so on. And this was one of the points which they always asked us, don't you have a solution for us? Can you do something for us? Especially there you do such great stuff. Isn't there a tool for it?
Exactly. Yeah. So I think the main goal for us is that we want to serve our researchers. And I think Sandra and me are a perfect fit for that because I'm a computer scientist. So I was a software developer by myself for many, many years. And I'm really into new technologies. And Sandra is more like on the scientific side. And then here science and technology have a perfect match. And so we work at Digital Labs. So we are really interested in new technologies. And this is where we saw, okay, there's a problem which exists since the beginning of science. So it was always a problem. What's intellectual property and how can I claim it? And now we see a chance to solve this problem.
And do the scientific researchers see it that way? I mean, is this something that people automatically trust?
That's another question. So we have a lot of scientists who see the potential and who are already using the technology and certifying their research data. But we really have to say that we know that this is a path which will go, at least the next 3 to 5 years until people will really realize the potential of blockchain technology. And we start by educating our researchers what is blockchain technology, because for most of them it's Bitcoin and it's darknet and it's money laundry, but the technology itself is really useful, and this is why we try to educate them. And I think it will take a couple of more years until they really will use it.
And in the meantime, I guess it's down to you to demonstrate convincingly that this is not just flash in the pan thing, but it's something that's got real practical application that's going to be useful to them in the long term. I mean, I assume that most of the people that you have to deal with are good with the concept of databases. The difference here, I guess, being that this is something that gets written into a database and they can be sure that it's going to be there without alteration some years from now.
That's exactly it. So a blockchain infrastructure is basically just a database with a consensus algorithm. So this means that everyone is in the position of the database or the ledger, which is called in the blockchain. And you need a consensus algorithm showing, okay, what can come in and how it goes out. And so it's very transparent. Everybody can see what's happening all the time, and it's not changeable. So you cannot go back in time and change anything.
Mm-hmm. And what you can add also is it's a matter of trust and reputation. So in science, the fact of reputation is really, really important. As a scientist, especially in biology, you want to publish in high gloss journals. The impact factor should be high because it makes your career. And it's because in the first moment we were thinking about using Bitcoin blockchain or other blockchains, but because of the reputation fact, we changed our plans and said, okay, then we have to develop our own blockchain before we can provide services on it. So this was the starting point. And the reputation, if you ask researchers, do you want to give or do you want to be certified by nodes, which you don't know in principle, or a network you don't know, or you want to certify, your research want to be certified by a consortium of universities and research organizations, makes a big difference.
So who can use this? I mean, if I'm not at one of your universities, but I'm someone who collects data or does research sort of thing, is this helpful?
It's a public blockchain, which means everybody can use it, but the nodes are only allowed to maintained by research organizations. And this is one of the big difference to other blockchains in the world. So everyone, a scientist or not, can certify whatever of data with bloXberg.
Mm-hmm. So we have a free API which everybody can find on our webpage. So everybody can use this API to certify research data, and we also have a Certify app, which is also linked on our homepage. So everybody can upload his data and certify his data on the bloXberg blockchain.
And as you mentioned before, it's not that you're storing that data, you're storing a hash. And I guess this is something I should have asked before. What's a hash?
A a hash is basically a fingerprint of the data. So you can compute a hash, and it's describing the data. So it's a string of numbers and characters. I don't know, 182 or something like this, and it's always unique. So if I have a text file and I only change one character, it's a totally different hash, and it's a one-way function. So you can always, from one data, you always compute one hash, but you cannot compute from the hash the data. So it's a one-way function.
So we can hash the podcast, for example, after this session.
Yeah, yeah, we put it on bloXberg. That's great.
Really? So I guess nobody can claim my Nobel Prize. So, great, let's do it.
Yeah.
Now, I'm not 100% sure that what we're doing right here is science. bloXberg's meant to be for scientific research. Do you make the distinction between science and not science? Is that something that you choose?
No, we don't. So I think this is something which is very subjective. What is science? What's not science? So we only provide the infrastructure. So basically, I could certify my private holiday pictures of my kids there. So there's no restriction. So I think the value at the end is that when you have to claim research data, you can do it. And if it's 90% trash you're certifying, doesn't matter so much, because computing a hash and putting transaction on the blockchain, it's not very computing intensive.
But you can't see it on the blockchain, what's behind the hash.
Right.
This is also for researchers quite interesting if they don't want that someone else sees, oh, okay, Sandra has make a hash over her microscopic picture, for example. I don't need to add any kind of metadata, so what's behind the hash, no one knows.
Okay, so let's say I do have some valuable data, some actual academic research, but I'm not a computer scientist. I don't know how blockchain works, and I'm kind of frankly intimidated by the idea of somehow uploading all of the research material, verifying it in the blockchain, making sure it has a hash, that it's somehow embedded in the data. I don't know. I mean, is there some sort of interface or app or tool or something between the blockchain layer and the research layer that makes that all a little bit more approachable?
So what we are doing at the moment, and what we already did, is we have, for example, for especially our research in the Max Planck Society, a tool which is called Keeper. It's kind of a sync and share and archiving tool, and we connected it directly to bloXberg. So with one click, you can certify whatever you want as long as it's a digital asset. And it is saved, archived, and certified in the same moment. And as a researcher using this Keeper tool, you don't even need necessarily to know about the blockchain technology. You know, okay, when I push the button, when I press the button, then it's certified. And maybe some years later, someone asks, okay, but did you do it really 2 years before or so? I can validate that again.
Exactly. For us, it was really important that it's not a big step to blockchainify your research data. So you can do it along your research without really needing extra tools or something. Because at the end, I think at the beginning, most people even don't know, will this become really successful or not? So when you start using data or processing data, you can just certify it, and probably you will need it in 5 years because you will get the Nobel Prize or not. But you can do it at the beginning.
So I guess the key to being around in 5 years would be critical mass. Is there much that's already registered in bloXberg, or would I be putting in the data hoping that others would eventually come along and do the same?
So I can check our block Explorer, and I can say how many transactions we have.
So everybody who wants to find out goes to bloXberg.org and can have a look at the bloXberg Explorer. There you can see all so-called validator nodes, so all universities and research organizations who are validating and certifying your research or whatever kind of data. And you can, so it's fully transparent. You see all the transactions, how long you need for creating one blog, and how many is already done.
And we now have over 10 million transactions on the bloXberg blockchain.
Okay, wow, that's pretty substantial. Presumably this isn't all just people uploading research data, though. I mean, 10 million transactions suggests that people have found some other really practical use cases.
Exactly. So we are currently working, for example, with a third-party project, and they are putting a community token on the bloXberg blockchain, which means that it's a project from Africa, and they want to have a technical token, so which is more safe than the currency of the countries, and this can also be put on the blockchain. So this is a very different use case. We have another use case, which is called peer view, where people can aggregate their peer reviewing activities, and they have like a decentral ledger of all the activities which they have done for different publishers, but it's stored on the on the bloXberg blockchain, so it cannot be altered by any publisher. So it's really different what you can do. So there are lots of ideas out there, and most of them are pilots, but we really have some productive services.
I mean, I guess like the web, this is as much a cultural and social infrastructure as it is a technical infrastructure. Is there a political dimension to this as well?
I thought this is a technology project, but really, it is a project about democracy. So how do you build democracy in a decentralized system? And so this was for me the most interesting point. I thought technology will be difficult and hard to understand, but setting up the governance model and bringing all these people together, this was really hard work.
So in a way, what you're trying to do is solve the issue of things like exploitation in the academic domain.
Of course, yeah.
So we trust the network, which is for, I think, a human brain is sometimes really not easy to understand maybe in the first moment, because it's not a person, it's not an institution, it's a network.
Yeah, for me, I always think of trust as being something that's about transparency on the one hand, but also about humanity, about coming to know someone in a social setting and making an evaluation of that person's character. I mean, we talked a little bit about unintended consequences. What could actually go wrong here? I mean, if we're replacing human interaction and kind of traditional ways of thinking about trust with algorithmic compliance.
So hopefully not that we are building the Borg, the Borg consortium. Hopefully not.
Nice that you can get a Star Trek reference in there. But I guess it's a legitimate concern. How does the human governance come into this? I mean, do you monitor the transactions, look for people who are not maybe acting appropriately?
Yeah, so we are, and this is the speciality in consortium-driven blockchains. So the work is in the consortium. It is that we talk to each other. We call it off-chain. We can take the phone or the computer via Zoom meetings, can talk to them. And there are persons behind it. We know all institutions who maintain and validate validators and maintain a node. And so there is a transparency and a transparent system. If someone will not behave in the proper way, then it's like in a democracy, we have to vote, and there are really a set of rules. If you not behave, then there are votings, for example, against this member and so on.
I'm not sure if it's a solution, but it may change our way of thinking about trust, because in blockchain technology, the trust is shifted from a central unit like central bank or central governance to a decentralized system where trust is code. And I'm not sure if our society is ready for this now, but I think it might be in the future.
All right, cool. So what's next then? How else can scientific research be automated, enhanced, or affected by digital technologies?
in my dream, it's already there, like an Alexa in a lab, but the Alexa is not going to a central computer. It's going in this way to the Max Planck computer, if it's for Max Planck scientists and so on. Unfortunately, we realized it's much easier to buy trousers or whatever via Alexa than to ask, okay, what are the 5 papers I should read today, or which 5 papers I missed yesterday? This is a really, really hard questions, even in our days.
Hang on, are you talking about a sort of an AI assistant for scientists? How close are we to something like that?
So the thing of it should be easy, like the recommendation of 5 papers, but the AI has to know about your research, especially it is very specific to your person, and so it has to be trained by yourself. Even questions like, okay, tell me how many papers are using this or that buffer, this kind of antibody for my staining or whatever. And this is hard. These are really hard questions for an AI still. And we didn't expect it. And I think maybe now we come to a point when I say, okay, we have maybe some commercial companies who are at least have something like, okay, they have a pool of material and methods, and the speech assistant can read these methods protocol like a recipe. Something like that. I think this is one of our starting point this year.
When that can't be so far away, though. I mean, personalized recommendation engines are getting pretty good, right?
So we are now looking for the board computer in the laboratory. So this is Sandra's dream. So standing in the lab and just asking the board computer, okay, what do I have to do? How many ingredients do I need there and this? And now I want to build that. And so that he's telling you everything you need for your science. So we thought this is not so far away, but as we now evaluating, so speech assistance in the lab is really difficult because we have a lot of foreign researchers, so there's a problem with accents. The speech is very domain specific, so you need special vocabularies in the lab. And so this is more challenging than we thought at the beginning.
So it aims to create a sort of a disembodied research assistant, or I don't know, PA. So what is the big advantage of that?
In my opinion, it makes your life, especially, for example, I'm thinking more in a laboratory. Of course, can be also transferred in other research fields. But in a laboratory, for example, might be easier and more efficient and having fun. Because if stuff makes fun, you're more happy, and then I believe then your research is also much better.
Okay, fun's a pretty good reason. I like that. I worked for a long time in universities doing research for a living, and I don't know if that was ever considered one of the main objectives of anything we were doing, though I do have to say we did go out of our way to make it as enjoyable as we could. And I've always thought that it doesn't always have to be miserable drudgery in order to be good work.
Yeah, if something makes much more fun, and I think especially researchers are in a way like they trying stuff out, they like to play around, they have to play around with solutions, whatever, and then it's you like to go to work, you like to go to do research, and of course if your hands are free, you don't have to hold your laboratory notebook, you don't have to hold something else, your hands are free for the real stuff like pipetting cells and so on, and you're listening via voice assistant to, okay, now add 3 microliters of this and that solutions to it. Then it's also, especially in a lab where you have to work under a sterile bench or so, of course, contamination of your cells is reduced, I bet on this, especially if you're start your PhD, for example, have to work a lot there. It's you're not used to it, and you have it in your ear, for example. You listen to it. You can always stop it in my dream. Okay, stop. Okay, now I add, instead of 50 microliters, I add only 10. I had to do it again. It's also protocol so this is still my dream, but you can have a protocol. It's already written somewhere then in the end, recorded and then written somewhere. So also your research is more... it's more recorded. You have it because this is something which researchers at the end of the day to write it down what you have done, and you can't forget it because it's already recorded.
Yeah, I love that you get to make this stuff up for a living and then go and make it happen. It's kind of the dream gig. This is sort of geek heaven, right?
Yeah, it is.
Yeah.
So we love our job. So
and it's not a job; it's fun.
Is that something that can be replicated? I mean, how do you go about getting a role like that?
I think it can be everywhere. So Digital Labs department started 3 years ago. And so we started it because we came up to our boss and said, okay, we really have to look at new technologies and try something out. So it was like it was not top down, it was a bottom up decision to start a Digital Labs. And I think if people are enthusiastic about what they are doing, they come up with new ideas, and you just have to let them do it. So it's how we lead our team. So, and I think if bosses are more into this mindset of just, using the enthusiasm of the employees, this comes up automatically.
Mm-hmm. So I think, our director supports us really, really great in a great way. And also the Max Planck Society did really a great, I think the Max Planck Digital Library is now 20 years old, and that a society like the Max Planck Society decided to have an institution like us is also a decision. Not all of universities and research organizations has this kind of central institutions. And I think we are grateful to work there.
I guess that level of autonomy requires the right context. You probably need to be in some sort of well-funded public body, I guess.
I think we are in the unique position that we can work freely without really looking, can we earn money with this at the end, or do we find an investor for this? So, and this really gives us the freedom to think, okay, what's the best product? What's the best thing we can do for our researchers? And I think this is the key for it. So we don't have to look for numbers.
Okay, so you've got bloXberg up and running. You've got all these amazing partners using it around the world. What's on the horizon? What's the next big landmark on the timeline for you?
So for me personally, the next landmark is that we see our researchers really using applications on top of bloXberg. So now we build up the infrastructure, but the infrastructure is of no need if nobody uses it. So I want to really see people using our infrastructure.
And hopefully next year we will have a summit where all research institutions and universities come together and we see us each other analog, not in a digital way, talk about bloXberg. So this is because this year we couldn't do it. So hopefully next year we will have it and celebrate then the second years of bloXberg.
Thank you both so much for your time. We're really looking forward to being part of that and working with you both in 2021.
Thank you so much, Andrew.
That's Sandra Vengadasalam and Friederike Kleinfercher from the Max Planck Digital Library and the creators of the bloXberg blockchain infrastructure for scientific research. And that's the MTF Labs podcast for this week. It's so nice to be back. It's great to have you back here with us. We've got a fantastic lineup of brilliant minds from the MTF community all ready to chat with us about cross-disciplinary innovation, technology, creativity, ethics, philosophy, policy, industry, education, inclusion, environment, new human capabilities, and all of the other important themes and grand challenges that they wrestle with and collaborate to solve and advance at MTF Labs. So hit the subscribe button and don't forget to share, like, rate, review, or just mention the podcast in conversation to someone in your next Zoom call. I'm Andrew Dubber. That's the MTF Labs podcast. We'll talk soon. Cheers.